Hi guys, so the last part of this unit is looking at another type of graph, and these are called phase diagrams, and they're different from heating and cooling curves because we're not just looking at how adding heat makes the temperature change or not change. We're looking at how pressure also can affect the phase of matter and what temperature a phase change would occur at. So the shape of a phase diagram, it kind of looks like the letter Y. So it goes like that and then like that. Okay. And not that you'll have to draw one of these, but you do have to be able to label what's going on and answer questions based on a diagram that you're already given. Okay. So, what's happening here? If I look at my temperature axis, so my temperature starts off low. This is going to be your water in the solid phase. This is going to be where we have ice. This is going to be water in my liquid phase, and this is water in the gas phase. Okay. And each line represents where a phase change would occur. So here, if you cross over that line, you would have melting. Okay. And if you follow down, that would tell you the temperature that we're melting at. Crossing over this line would be when the substance or the water is boiling or vaporizing. And then at certain temperatures and pressures, you can actually get water to go solid directly to gas, which is called subliming. Okay. So now, what else do we have going on here? We have this little section in the middle of the graph, and that's called, I'm going to label that as a big spot. That's called the triple point. And that's when you have all three phases existing together. Okay, so you have to really make the temperature and the pressure just perfect to have ice, liquid water, and steam all in the same container. There's also this spot up here. Okay, and that's when the temperature and the pressure is really it's the temperature is so high that it's impossible for the substance to turn back into a liquid. Okay, so I'll label that as a star, and that's actually called the critical point. And we'll say the temp is too high to liquefy. So steam would not condense. It would be impossible to make it condense at that temperature and that pressure. Okay. So another example of another substance we have is carbon dioxide. So again, guys, all your phase diagrams, they're going to have a similar shape as one another. We're going to have our solid, our liquid, and our gas. What's going to be different here is what temperatures our phase changes occur at. We know that carbon dioxide is a gas at standard temperature and standard pressure, where water is a liquid. So the melting and the boiling points of carbon dioxide are going to be lower if these graphs had numbers on them than for water. So how do we know what something's melting and boiling point is? At 1 atm, 1 atm is standard pressure. So for water, 1 atm would be up there, okay? And it would be melting at around 0 degrees Celsius and boiling at about 100 degrees Celsius. So if you follow that 1 atm across, we hit the melting line at 0 and we hit the boiling line at 100. Okay, so at standard pressure, those are water's normal melting and boiling points, and that's what we would see. For carbon dioxide, since carbon dioxide is a gas already at standard temperature and pressure, our 1 atm would be down here. We would actually be able to see carbon dioxide sublime. at standard temperature. We're not going to see water turn directly from a solid to a gas, right? It's going to melt first. But for carbon dioxide, it will turn directly into a gas because it's so hard to turn carbon dioxide into a solid. You have to make it so cold and make the pressure so high. Okay, so that's just something cool about carbon dioxide. All right, so what you guys have to be able to do is basically answer questions about a graph like this. So you have to know the phases and the phase changes. So let's look at this practice question together. Label each phase on the diagram. Okay, we always have solid, liquid, and gas. Circle the triple point. So the triple point is where all three phases intersect. So that's going to be right there. What is the significance of this point? I'm going to let you guys answer that. Okay, what is the normal melting point of this substance? So guys, normal means that we're at STP, which is standard temperature and standard pressure. So standard pressure is 1 atm. So they just want me to look at 1 atm and follow it across to where I'm going to start to melt. And if I look down at this temperature, my normal melting point is negative 15 degrees Celsius. So the word normal just means you have to read the graph at normal pressure, which is 1 atm. Okay, I'm going to let you guys figure out what the normal boiling point of the substance is. Okay. Number 5, at what pressure would we be able to see this substance sublime? I'm going to let you guys answer this question as well. Okay, let's look at number 6. At the pressure of 0.75 atms, okay, so now we're talking about like right here. What phase would the substance be in at 15 degrees Celsius? Oh, negative 15 degrees Celsius. All right, so let me erase some of the lines I have here already so that this doesn't get confusing. All right, so I'm at negative 15 degrees Celsius, and I'm going to see where these two lines intersect. They intersect right here. So what phase would the substance be in? It's almost as if you're plotting a point, guys. So both of those lines met up in the solid phase. Okay. Now for B, it says if we increase the temperature to 140, so to increase the temperature, that means my spot that I just drew would be moving over here to 140 degrees Celsius. What phase changes would occur? So you want to look at what lines you passed. You passed the solid to liquid line, so I know that my substance melted, and you passed the liquid to gas line, so you know your substance boiled as well. Okay. Finally, are these phase changes exothermic or endothermic? I'm going to let you guys answer that one on your own, and I'm going to let you do number 7 on your own as well. Okay, we will go over this next time I see you in class, and I hope you guys have a good day.